Hello everyone, I am SHASHANK and I did a systematic review on the effects of pulsed electromagnetic fields on osteoblasts and osteogenesis. The research problem of my paper is there are insufficient evidences to show the mechanism of action of pulsed electromagnetic field on osteoblastic differentiation, proliferation and osteogenic differentiation of mesenchymal stem cells. The objective of my study is to assess the available evidences on the effects of pulsed electromagnetic fields on osteoblasts and osteogenesis. I did a detailed search on in vitro studies published from the year of 1998 to 2020, listed in the PubMed database in accordance with the PRISMA guidelines using systematic and electronic hand searches. The results of these studies reveal that the stimulation by pulsed electromagnetic field has shown to increase osteoblast proliferation and differentiation and promote differentiation of mesenchymal stem cells by various signaling pathways. The pooled results of these studies in this review revealed that the effects of pulsed electromagnetic field on osteoblasts and osteogenesis has proven to be of methodological quality. I'd like to thank the orthopedic community that has played a central role in development and understanding of the importance of pulsed electromagnetic field. The pulsed electromagnetic field, like any other pharmacological modality, requires care and precision in its use to ensure success expected of it by the physicians and the patients. The key words which I use to determine the articles are osteogenesis, osteoblast, and pulsed electromagnetic field. Pulsed electromagnetic field is a new and growing treatment modality which is not only used in treatment of bone tissue disorders but is also used in regenerative therapy. It is a non-invasive method which is administered using coils. It increases and promotes bone repair and decreases osteolysis. It has effects on osteogenesis in a cellular level by altering the morphology of the mesenchymal stem cells and osteoblasts. The cell membrane is the target and site of interaction of the pulsed electromagnetic field, through which it signals and activates a cascade of intracellular and intercellular events. The principles that are followed by pulsed electromagnetic stimulation are as follows. The ability to act selectively on cell targets. The signal specificity should be identified, which are waveform, frequency, duration, and energy. The dose-response effect should be identified, and last but not the least, it should be effective at the disease site. This is a diagram given by Zhang et al. In 2010, which represents the sites of interaction of pulsed electromagnetic fields on osteoblasts. I did a detailed search on in vitro studies performed between the year of 1998 to 2020, published in the language of English, and I used PubMed database to determine these studies. The obtained studies were evaluated for inclusion and exclusion criteria, and the details were analyzed and tabulated. These are my inclusion and exclusion criteria. This is a flowchart which represents how I selected the studies for my systematic review. Effects of pulsed electromagnetic field stimulation on osteoblasts. Osteoblasts are major cells for bone formation, bone matrix synthesis, and mineralization. There are many studies done about pulsed electromagnetic fields on osteoblast proliferation and differentiation. About 8 studies prove that there is an increase in osteoblast proliferation, differentiation, and maturation, amongst which 5 studies use the bone morphogenetic protein and alkaline phosphatase biomarkers to measure the proliferation, differentiation, and maturation amongst osteoblasts. About 2 studies prove that the primary cilium of the osteoblast acts as a sensor for pulsed electromagnetic fields. These are the studies which I have selected which prove the effects of pulsed electromagnetic field on osteoblasts. All the studies are color-coded according to the cellular proliferation, differentiation, and primary cilium. Effects of pulsed electromagnetic field stimulation on signaling pathways of mesenchymal stem cells. Mesenchymal stem cells are pluripotent immature cells which can differentiate to form any cell. It can be isolated from other tissues including spinal cord, bone marrow, fallopian tube, fetal liver, and lungs. Frequently used mesenchymal stem cells are human bone marrow mesenchymal stem cells, human adipose-derived mesenchymal stem cells, human periodontal-derived mesenchymal stem cells, and C3H10T1, which is basically murine mesenchymal stem cells. Various studies have been done to determine the signaling pathways for differentiation of mesenchymal stem cells. These are the biomarkers which were used to determine the signaling pathways of mesenchymal stem cells. These biomarkers are color-coded in the table for your convenience. These are the studies which are done to determine the signaling pathways of mesenchymal stem cells. There were about 14 studies which were done. These are my references. Thank you and have a good day.